So I'd like just to know from you is if everything is all right with the material, with the access, with the download and so on. Can you answer me, please?
Yes, Professor. For me, it was possible to download everything.
Okay.
By the way, the video I haven't tried yet, but the slides have been working.
Okay. So, but I think also that the video is simply another file. And so, if you want to download it, you can do. If there are problems, please inform me. But in principle, it should work. If you agree, I suggest to go on with this system. Unfortunately, the connection with the university didn't work last time, but I think that there is no problem if we go on with my Teams channel and with this folder where all the material is placed. So please, if there are problems of any kind, inform me. We could also change something. Otherwise, I think we could go on with our course with this possibilities. Another point to consider, I sent to you this this document that was a sort of test for the exam. I've received 25 answers, so it seems that this system works. And as I said last time, if you are interested, we can just organize two written tests, one in the middle, around Easter, for example, and the other at the end of the course. So if you agree, we could combine these two tests, and finally your mark will be the average of the two partial tests. Let me know because it seems that the system works well. I can prepare some questions for you, giving you a certain time, 1 hour and a half to answer them. Then you can have the first part of the exam done by April, and the second one immediately after the end of the test. I think in the middle of May, you could do the second part, and so by the end of May, my exam could be solved in terms of exam and relative mark. Let me know if you are interested in this option. Some ideas are ready now, or should we postpone the decision for the following lectures? What do you think? You no ideas?
Well, if we fail one of these tests, intermediate tests, we can go to the test on after the course.
Yes, of course.
Okay.
This is something more to the normal to the normal exam. So if you can, if you fail the one part, you can repeat only this part during the official dates of the exam. But if you fail both, there is no problem. You can do the exam during the official dates as usual. There is nothing, no limitation given by the intermediate tests.
Okay, thank you. Well, I would agree. So I don't know the others.
Okay, there is one.
Yeah,
Yes, please.
it's a good idea for me too.
Okay. So other opinions, if you want to think about this option, we
Yes,
can.
I prefer have the exam in 2 parts.
Okay.
Yes, the same.
Yes.
So I think that it could be a good idea also for you. Uh, can some of you provide to me a sort of summary of the students who are interested for the next time or for the next days? Just collecting all the opinions in order not uh, to waste time today. Who is the tutor of the course? There is no tutor.
Not yet.
Not yet. Can one of you can do this little work for me, please? Just collecting all the opinions and send me back a list of the students who are interested in this option of two little tests instead of one full exam. There is no candidate.
Well, I could do it for Italian students.
Okay, so Giovanni will do this for the Italian students, and one candidate for the German students. Who could be? I see on the right, Clara. Can you do this for me? Clara, May.
Yes, I can do it.
Okay, thank you, Clara. So it's not urgent, of course, but if you can prepare this list for me, it will be good, and I will appreciate your contribution. So thank you. So this will be something we will consider again during the next lecture, of course. So what else? Okay, these are simply the dates of the next lectures. Normally, I prefer to define the dates in advance. This simply because sometimes there are some holidays or I could be involved in some other meetings. But for the next week, everything it's all right. Of course, you could also have some impediments due to other exams or something like this. So I think it's good every lecture to consider the next dates and possible change if there are some problems for me or for you. I think that's all. Okay, so today, as I said at the beginning, we are going to start the first part dedicated to wood. We'll have a break in the middle, so after 1 hour, 1 hour and 15 minutes, we'll have a break for coffee or tea or something else. And then we will continue until we are still in good shape. I think normally we could finish the lecture around 5:30 or something like this. But it depends on how we will be able to go on and to maintain our concentration also using these systems. Okay, this I think it's all for the Blackboard, and now I have to pass to the presentation. That is this one. Okay, now I think you should see my presentation with the first slide where it's written the name of the course, Furniture Technology, Materials and Technology, and this is part 1 dedicated to wood. Is everything all right?
Yes.
Yeah.
Yes.
Yes.
Okay, so let's start with this interesting subject, wood, and let me tell you what we are going to do. I think this part will be split in I think almost 3 lectures, because there's a lot to do, a lot to learn about wood. We will start with a short introduction. Then, as I said also last time, we will consider how this material is made by nature. So we will start with the morphology, so with the shape, with what we can see with our eyes. Then we will enter inside this material, considering its anatomy. So we will use a microscope to see how nature produces this material. Then we will continue this trip inside wood, coming to the molecules, going in more details with the chemical composition of wood. Every time we will analyze how wood is made, but from this we will derive immediately what are its properties. Then some notes about nomenclature and classification, some notes about woodworking. An interesting part is that of safety, because normally wood is considered a safe material because it's natural, because it's derived from nature and so on. But we will discover that every material it's can be dangerous. So the adjective natural or artificial has nothing to do with with the safety of substance of a material. What is important is the composition and the possible interaction of such substances with our body, with our biology. This will be, I think, something also surprising to you when we will consider if wood is safe or not. And finally, something we have already mentioned, the part, this appendix dedicated to modified wood. Modified means that it's possible to change its composition, acting with physical or chemical processes. And so the material which derives from such modification normally improves the performance, improves certain properties in order to be better used for certain final application. So that's it's all for the general program dedicated to woods. We start, as I said, with the general introduction, and when I present woods, I normally start with this graph. You know very well, I think, that the history of humanity is very often divided in ages. And ages refer to the material or the materials or the technologies that were used in certain periods of the human evolution. So we see, for example, that more than 7,000 years ago, we were in the Stone Age because humans used stone as the main material for the daily use. Then some long ages where metals were the main protagonist of the human life, Bronze Age, Iron Age. Then in the more modern periods, we see steel, concrete, then the polymer, plastics, coatings, adhesives, and so on. This evolution started roughly after the Second World War. Then in the more recent times, we know very well that the computers are the most important tools of our evolution, so the Silicon Age. And in these last years, we are involved in this information age. Every moment of our life, we know we are connected with someone else, or we are connected, for example, like in this experience for our lecture. We have our mobile phone receiving messages or going to the social programs and so on. So this is what is normally presented also in books, in publications, and all other references related with the human evolution. But this is what I normally add. This long bar you see at the bottom is added by me, by Franco, and because I think that normally no one considered that for sure the first material used by humanity was wood. If you think to, for example, huts, if you think to weapons, if you think to daily tools, or also to fire. Fire it can be considered one of the most important discoveries of the human beings, and fire is strongly connected with wood. So for sure, wood was the first material used by humans, and in all the ages was the main material for many different applications, and still today it is. I said last time that buildings are produced with wood. Furniture that presumably you have around you are produced with wood or wood derivatives. Paper, books, and so on are made with wood. Packaging, also energy production. It's increasing the use of wood for energy production. So wood is still today a fundamental material of the global economy. And as we will see immediately after this slide, the use of wood, the production of wood is increasing all over the world. So remember, we are in the wood age. We were in the wood age, and we are in the wood age. These are some figures telling exactly what I've already said. This is the production of sawn woods used, for example, for buildings. And you see that during the last years, the production has increased every year in every continent. Because you see here for example, the green bar is represent Europe, but also wood-based panels, particle board, plywood, and so on, is increasing, and for the next years, there will be also continuous growing of the production of wood-based panels. We have seen last Wednesday that we are around 400 million cubic meters per year of this important construction material. The industry of paper is more or less stable, we can see in this graph. What is increasing a lot is the production of, here the figure tells us about the production of pellet. Pellet, you know, is used for heating system, domestic heating system, but not only, also for the production of energy. And you see how this energy source is increasing more or less all over the world. So the use of wood is increasing. This is what the statistics tell us. I found this data into internet sites. The furniture market is valued around 610 billion in 2019, and apart from the problem of the COVID-19, but in principle, the tendency is to grow for the next years, and the same is for wood used for buildings. It was estimated into roughly 300 billion 2 years ago, and it is expected to reach $400 billion in the following years. That is also interesting. For example, in Italy, I don't have the numbers, but I know very well that the building sector is decreasing because there is no need of new houses and so on, or new new places for new buildings for production companies. We know that the crisis and so on, but the wood building market is increasing. So despite the general building sector is suffering a lot, the specific part dedicated to wood buildings is increasing. This is the figure I have for Italy, but I think it's similar also in other countries, especially here in Europe. Some nice pictures about construction made of wood. This is something, don't remember the town, it's in Spain. I don't remember, it's Valencia or Seville.
I think it's in Sevilla.
Sevilla, okay, yeah. This is in Germany. I don't remember the town. It's quite new construction made with wood. This is a project of an important architect for this skyscraper. It's a project. It's not. It's not a real picture. This morning I found another project of a building completely produced with wood and glass in Milano. Exactly this morning I took this picture and this other two, and you see how wood is present, ceiling, floors, and so on. So wood is really the material of the past, but also of the future. And again, other products, that can be produced with wood, furniture, boards, airplanes, flooring, pencils, wine barrels, musical instruments. So really wood is everywhere. Okay, some good and bad news about the forests, because we know that wood comes derived from the forest. These are some data I found some months ago, and it tells us that there are some bad situations like Africa. You see that 10 years ago the forest area was quite big, and during the following years deforestation has dramatically reduced the total forest area. In Asia, the situation is different. The total forest area is increasing. The same is for Europe. What about the America? More or less stable. North and Central America. Oceania, stable again, and again in South America, similar to Africa, the total forest area is decreasing. So there are some parts of the world where the deforestation dramatically reduces the total forested area. In some other parts, as we will see, people is considering how important are the forests, and okay, we use trees coming from European forests, but we continue to plant new trees, and so the final result is that the forests in Europe are increasing in terms of number of trees and forest area. Some other interesting figures. These are the primary forest, so virgin forest, and you see that the difference in the last 10 years was negative for Africa. Also for Asia, Europe a little positive. Normally, this figure is negative for the entire world. So it means that unfortunately the virgin forests are decreasing. The expansion in our countries, in our continents. But the good data is this one. These are the area of planted forest. So today we can say that trees are cultivated like potatoes, like tomatoes, like every other product of the agriculture. So they are planted, they are cut after some years. And what is interesting is that in every continent, the area of planted forests is increasing. So this is a new trend of the use of wood. So today we don't cut trees from virgin forests, but in principle we cultivate trees, and we cut when they are ready to be cutted, and we plant new trees for the future generation. So it's a very good, I think, piece of information, considering that the wood that we have around us is produced by men, by specialists who are able to cultivate trees and to produce wood from this planted forest, not from the virgin forest, which should remain virgin for the future generation, with all the diversity inside them, not only in terms of trees, but also in terms of insects, animals, and so on, in terms of global biology. Okay, so good news and bad news about the trees. So how is possible to counteract illegal logging? Logging means the cutting of the trees. As you see in this picture, there are many areas of the world where trees are cutted from virgin forests, and this presents a serious problem, as we have seen, for the future of many species, vegetable and animal species. How to counteract these disasters, these environmental disasters? Europe and also other continents, other countries has implemented some special regulation. In Europe, we have this EU regulation 995. That it's very often called the illegal timber regulation. It starts from the consideration we have already explained, that forests are important for human beings, for the environment, for the biodiversity, and so on. And so this regulation, which is a law which is valid in all Europe, establishes some particular obligations for timber operators. As you can read here, the importing companies are required to apply the due diligence, means that they have to know what they are importing in the European territory. For example, the name, the trade name of the product, the country of origin, the amount of material imported, and all the documents establishing the conformity of the product to the EU regulation. In principle, when you import, for example, furniture from an extra EU country, you have to collect all the information to know from which forest the wood used derive. It's not easy, you can imagine. If you, for example, you are an importer of office desk, for example, that are done with the particle boards. If this office desk comes from extra EU countries, you have to collect documents telling you from which forests the wood used derive. The importers of wooden elements, the big ones, of course, they have specialized offices dealing with this matter. So it's a very, very, I would say, complex, but the goal, the aim of this EU regulation is to prevent the disasters we've seen in the previous pictures. So a similar regulation, for what I know, is in force in the United States. So also in this country, the importers of wood or wood-derived products has to deal with something similar to the European regulation. Another something that is more or less related with what I've already said is the wood certification, or certification that involved products derived from wood, paper, for example. There are two certifications. The first one, the most famous, is the FSC, which is managed by some environmental organization, you know, I think very well, the WWF, Greenpeace, and many others. So this certification tells to the final consumer that the product was produced with wood derived from controlled, from sustainable forests. The same is the other certification, TEFC. This certification is managed by the wood producer or importers. So it's a little bit different from this one, from the FSC. And sometimes the companies dealing with wood materials or wood products, they have to deal with both certification, because, for example, some clients could ask for this, for the FSC certification, some others for the other one, and the two certification do not mutually recognize themselves, and so very often the offices of the companies, for example, of the furniture sector, must deal with the two similar certifications. For example, they have to face two audits per year, one from the FC inspectors, the other from the TFC inspectors, and so on. You can find especially this logo in many products derived from paper and so on. Also in your daily activities with what you eat, the containers, the packaging, the receipt you get when you buy something. If you see on the back, very often you can find this logo. In Italy, for what I know, also the tickets of the railway are printed with paper, which has this certification and so on. So, in terms of global requests, these are two important reference points for companies dealing with wood or wooden material. I start mentioning the most important furniture marketing company, which is IKEA. I think you know very well. It's a Swedish company, and they require their suppliers for this FSC certification. So if you are a supplier of this big Swedish group, everything you use must be certified with this logo, with this mark. Okay, I think this is more or less all for this first part dedicated to the importance of wood, where it is produced with the problems of the deforestation. We have seen also the how to counteract illegal logging, and something related to this, the two voluntary marks, voluntary certification, the XFC and TEFC. Okay, this is the general scenario of wood use, but I would like to ask this question now, but why still wood? Okay, we have seen, we have shown different uses, buildings and so on, but why should we still use wood and not other materials, steel, concrete, plastic? Why we are still in the wood age? And here there are two main reasons. The first is that wood is sustainable. I think I've used this term also during the first lecture. Today, we continuously speak about sustainable production, circular economy, sustainable economy. This also during this pandemic period, if we look to our future, one of the possible evolution of the market is said to be the green market, the production of green products, sustainable products, environmental friendly products. So these terms, I hope you are familiar because we can read or listen every day the newspaper, at the television, and so on. What's the real meaning of sustainable? I've reported here the definition given by an ISO standard. ISO is an international standard, so it was developed by experts coming from all the world. So it's a general reference that is valid for every country in our world. And this document says that a sustainable development is a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And here you see two pictures. We can derive that this plantation of trees is sustainable because we can cut the trees, plant new trees, and our sons and our nephews and future generation, we will see the same picture, and they can again cut the trees they need, plant other seeds, and also for their sons, their nephews, they can go on looking at the same pictures. On the right, the situation is completely different. This is one of the disasters we have caused using, for example, plastic. You know that there are some plastic islands in the oceans, which for sure do not tell us, give us an image of something sustainable. Here we are polluting, we are destroying our worlds, and the future generation will see this picture, or even something worse if we go on in this way. So wood is sustainable by definition because we can replace, we can produce what we use now, and the future generation can meet their own needs with the trees we have planted today. So wood is sustainable by definition, and sustainable is a priority for the current market and for the future market. So why should we use wood? One answer is because wood is sustainable by definition. But this is not the only reason to use wood. There is another important reason, because we must use still wood because it counteracts the greenhouse effect. Do you know what is the greenhouse effect? Some ideas from you? Do you know what is the greenhouse effect?
Yes, is the responsible of the increase of Earth temperature.
Yeah, you are right. But where the greenhouse effects comes, you can read here in this chemical very simple chemical reaction. When we burn something, for example, methane or every other energy source, the burning means that there is a chemical reaction with the oxygen, and the product is energy that we use for industries, for our heating system in our houses, or for our cars. So we produce energy, that is what we need, but we produce as byproducts carbon dioxide and water. So you see yes, that the emissions very often are white because they contain molecules of water. So the burning of the propellant produce water and carbon dioxide. How much CO2 is produced, for example, by 1 liter of methane burned? You see here that for every kilogram, we produce roughly 2.8 kilograms of CO2. Gasoline, for every liter, 2.4 kilograms of CO2. And for diesel fuel, something similar, 2.6 kilograms. So let's consider these questions. How many kilometers do you drive with your car every year? And how much fuel do you burn? How many kilograms of CO2 do you emit in the atmosphere? Please do this calculation. I think you know how many kilometers. How much fuel, it depends on how many kilometers your car does with 1 liter of gasoline or does diesel fuel. And then you can calculate, you can consider 2.5 kilograms for every liter. You can easily derive how much CO2 you emit in the atmosphere every year. These are my answers. Normally I drive around 15 1,000 kilometers every year. I have an hybrid car, so this is good. I can drive 25 kilometers for every liter of gasoline. So it means that I use my car uses 600 liters of gasoline every year. If I multiply 600 liters for 2.4, the total is 1.4 tons of CO2 that I personally emit in the atmosphere only driving my car. Have you done some calculation for your experience, for your car? No answers?
Yeah. I have one third of your result.
1/3, because you drive not so much.
No, especially during the pandemic.
Okay. Some others answers?
Yes, I made a calculation, and it was before the pandemic. It's with 20,000 kilometers a year, and I came up with 2.5 tons nearly.
Okay, 2.5 tons. So if you think it's a lot, it's really a lot. And if you imagine all the cars that are on the roads every day, the amount of CO2 emitted every day in the atmosphere is really dramatic. Billions of tons every day. And this is a graph representing the concentration of carbon dioxide in the atmosphere. You see that after the Industrial Revolution, starting around the 2 centuries ago, there was a dramatically increase in the concentration of CO2 in the atmosphere. There are some websites that gives you the daily concentration of CO2 in the atmosphere. If you try on internet, there are different websites which tell you the daily, which is the daily concentration of CO2 in the atmosphere. Why is it so important, this story of CO2 emission? Because as our friend said before, the CO2 produces this effect called the greenhouse effect. So it's for physical reasons related with the absorption of certain wavelengths. The CO2 is able to entrap the sun radiation, producing an increasing of the global temperatures, like in the greenhouse. So the solar radiation is not able to escape like we see here, but due to the absorption caused by CO2, which absorbs in the infrared range, causes an increase of the global temperature. And we know what happened in the climate of all the world. Temperature are increasing, ice is melting everywhere. There are disasters caused by storms and so on. So the general increasing of the temperatures all over the world is producing a rapid change of the climatic conditions with many and many dangerous effects for the human beings, not only. And everything is caused by the increasing of the concentration of CO2 caused by us, by our cars, by our heating system in our houses, by the production of energy, and so on. Why wood and trees are important in this story? Because here there is another chemical reaction you know very well, is the photosynthesis, telling us that when the tree grows, it produces biomass, biological materials, cellulose, and other substances, using exactly the CO2 of the atmosphere. So you see that the trees absorbs CO2 and water, plus the energy of the sun, and produces biological mass. So as you clearly see here, CO2 is subtracted from the atmosphere, and it is, we can say, stored inside the tree. So in this way, we can say that wood growth counteracts the greenhouse effect, because it is a way to subtract CO2 from the atmosphere, storing it inside the trees, inside the wood we use in our houses. So more or less, we can say that on average, through the photosynthesis, the tree absorbs roughly 1 ton of carbon dioxide for every cubic meter of new wood produced, and releases around 0.7 tons of oxygen. So when the tree grows, for every cubic meter absorbs 1 ton of CO2 from the atmosphere. You can see why it's better to use wood instead of concrete, plastic, and other materials, because if we use wood, we store inside our building, for example, some tons of CO2 subtracted from the atmosphere. Wood is a sort of carbon sink where we can store the excess of CO2. It seems something theoretical, not okay. It's interesting, a good, a nice story, but nothing that the reality that the politicians can really consider to counteract the greenhouse effect.
Today, I'm pleased to announce the United States will join 1 Trillion Trees initiative being launched here at the World Economic Forum. 1 trillion trees.
Have you listened what the President Trump said last year? Sorry, they decided to join this project of planting 1 trillion trees in our world. Do you know what? So listen again.
Today, I'm pleased to announce the United States will join 1 Trillion Trees initiative being launched here at the World Economic Forum. 1 trillion trees.
How many trees? 1 trillion. This is 1,000. This is 1 million. This is 1 billion. This is 1 trillion. So Mr. Trump said that the United States, together with other organizations, are going to plant this incredible number of trees in our world. And the reason is precisely what I mentioned before, because this means that all these trees will store a lot of CO2. I've read an article some months ago that if this project really reaches the goal, more or less the 25% of the CO2 will be subtracted from the atmosphere. 25% of the existing CO2 will be subtracted. It's not the solution, of course, because we are continuing to emit CO2. So but it's something that probably could give to the human beings more time to find a possible solution, because it's clear that we cannot go on to emit such big quantities of CO2 in the atmosphere, as we have considered before, are billions of tons every day. This is a way to counteract this incredible progress in the emission of CO2. And the hope is that during the next years, we will able to find some others sources of energy which do not involve the burning of fossil fuels, and so not contributing to the continuous growing of the CO2 concentration in the atmosphere. So it's something I think interesting for not for only for this course, but in terms of general knowledge. And as we have seen from this slides, it's something that the world is considering, and also our politicians considered wood as a possible, trees would possible, not solution, but a possible option to counteract the greenhouse effect, to have more time in the future to find possible alternatives to the current energy sources.
May I ask a question regarding to this, Professor?
Yes,
if you would go one slide back, please.
Yeah.
Because basically, I want to. You have said a lot of things also regarding the usefulness of tree planting campaigns. But
yeah.
What do you think? Is it just more somehow like a mind opener to people, or because I think it's also in the context of Donald Trump just used as a marketing campaign?
Oh.
And basically, at the end, you already said it. It's changing nothing, just to plant trees. But maybe there's a hope that speaking about tree planting campaigns is like a start or opening to the topic. And at the end, you also have shown us it takes a lot of time until a tree is including 1 cubic meter of biomass. So just planting a tree is maybe also useless at all when the tree is not growing and maintained as a healthy tree.
So the general idea is to plant more trees in order to subtract CO2 from the atmosphere. I hope this is clear. I don't know if what Mr. Trump said will be really done in the future. But for what I know, the project is real. Mr. Trump said that the United States will join, so it means that there is already a project. So they will contribute to this forestation project. I really don't know where they are, if this project has started or not. But when the politicians consider this a subject, it means that it's in the air. It's something that it's well known, that is considered in the right tables. I cannot say more than this. What I can suggest, for example, if you like this subject, you or your colleagues, maybe one of the presentations I've suggested last time could be dedicated to this project. So you can find in internet some news about the 1 trillion trees project. It has really started, how is organized, and so on. So did I answer you? Or?
Yeah, it's okay. Yes, I think so. And it's interesting that you take the connection to the presentation, because I was already thinking about the topic of bug beagles we also have as a big issues. And this would be a nice connection, and maybe I can take this part as well as a presentation. Then.
Yeah. Okay.
Okay. Thank you.
Thank you to you. No, I think it's enough. So the last point before our break, the coffee break. This is also interesting evidence of how the storage of CO2 is considered by the technical world, by the technical experts. There is this European standard, EN 16449, related to wood and wood-based products. And it's deal with the calculation of biogenic carbon content of wood and conversion to carbon dioxide. So the equation seems complex, but it's in practice very simple. For every wooden product, like a chair, like a table, like a cabinet, or whatever, you can calculate how much CO2 is stored inside. You have just to know what the moisture content of the product. If it is wood, normally you can use 12%. If it is wood-based panels, you can calculate 6-7%. The density of the product. But if you know the wood species, you can find it on internet. If it is a wood-based panel, you can calculate, you can consider 0.6 or 0.7 kilogram per square meters. And the volume, you have to calculate the volume of the element you have considered. So it's nothing so complex, just substituting the values in this formula. You can calculate how much CO2 is stored in your desk, in your chair, in every wood element of your house, your office, and so on. We have done here in CADA some calculation for a chair, beach chair. Inside this chair, 23.2 kilograms of CO2 are stored. In this cabinet, around 50 kilograms, and something similar, for this desk. So this calculation is used by some companies to market their products. So they sell the products saying, if you buy my chair, you save 33 kilograms of CO2. You store, you subtract from the atmosphere 23 kilograms of CO2. So it's a sort of new marketing tool for the companies, telling to the clients that buying their products, they do something in favor of the environment. It's not common, it's not easy to be explained, but it's something that it is already used by some furniture producers. And if you want, you can do this calculation for some of the furniture products you have in your house or in your school. Okay, there are some countries that consider some benefits for the companies who use energy deriving from wind, for example, from solar energy, from bio products, or which are simply planting trees. So they can emit a certain amount of CO2 in the atmosphere, and they compensate such emissions by this systems, including the planting of trees. So they plant 10 trees, and they can emit something more in the atmosphere. This is something that some legislation around the world are doing. Conclusion for this first overview of wood. So why still wood? It was the initial question, and the two answers we can consider are yes, because wood can meet the needs of building materials for present and future generations. Wood is sustainable, and also because the use of wood improves the environment, because it subtracts CO2 from the atmosphere, and so it counteracts the greenhouse effect and all related problems we are facing. Okay, so it's really this the last one, and then we can go to drink our coffee. Still wood, yes. I think it's right that I've said many good and nice things about this material, but it's right also to present the contrary, the problems that this material present in comparison with other materials I've already mentioned. And I think that the most important point is summarized in the first words: wood is not an engineered material. So wood is not produced by us. If we produce, for example, carbon fiber, we can use certain resins. We can use a certain reinforced material. We can add some additives and so on. So we can produce something that fits our needs. This is typical example for plastic, for example. If we need a flexible plastic, we can use plasticizers. If we need a hard plastic, we can use some reinforcing materials. In the case of wood, this is not possible. Wood is produced by nature, and so we can't modify in principle its composition during the production. There is something that we can do after, but we cannot change the ingredients like for engineering material I've already mentioned. So this is the most important weaknesses of this material. And so, as we will see later, we must carefully consider, study this material in order to properly use, protect when needs to be protected, or even transform it. We have already mentioned the modified wood, so there will be also possibilities to do something to the final material after the nature has produced it in order to modify some of these properties. Okay, it's 14:24. I think we can finish for the moment, and we can have I think 15 minutes for coffee or tea or something other to be ready again at 14:30. No, I can say 14:40. Okay, 15 minutes, and then we can go on until we are able to stand the lecture. Okay, so let's meet again in 15 minutes.
Okay.
Okay, so are you ready again?
Yes, Professor.
Yes, okay. So the first part of the lecture, we have introduced wood. I would like just to summarize what we have said. We have considered some figures about the wood market, considering how important is for many different products of the global economy, including buildings. We have also shown some interesting pictures of the future projects involving the use of wood. Then we have considered that the different materials coming from wood, sawn wood, wood-based panels, pellets. The production is increasing everywhere. And then the most, I hope, interesting part was dedicated to the reasons to choose wood instead of other materials. We have considered two important reasons. The first is that wood is sustainable. We have given a definition of sustainability, and wood is I said by definition a sustainable material because we can use and produce it at the same time. So the future generation can continue to use this material, and the same is not valid for plastics, in particular all the raw material deriving from petroleum cannot be reproduced by human beings. Okay, we can recycle, but also wood can be recycled. This is another option that also wood has. And the second reason to prefer wood is that wood counteracts the greenhouse effect. So we have quickly said what is the greenhouse effect, where it comes from, the effects we know what they are. Normally, when I comment the greenhouse effect, I say that I live in Udine, a little town not far from Pordenone. And when I was young, today I'm 60 years old, so I remember that 50 years ago, when I was young, I was used to during the winter time to go out and to play with snow. It was very common in Udine to have the snow. And today, snow is an accident, I could say, in Udine. This year we didn't have snow, for example, but during the last years, the climate during winter was relatively light, could say, not severe like it was 30 or or 50 years ago, with temperatures below zero for many days during the year. Today, it's an exception to have minus something and the snow also. So it's I think evident to all of us how the climate change is affecting our life, and as I said, the trees is a possible option to counteract, partially counteract the greenhouse effect, because they store CO2 when they grow. And I've also mentioned this initiative, the 1 trillion trees. One of your colleagues told me that could be some doubts about the real number, because trillion can be considered in a different way in the United States. Okay, it could be a reason to analyze this subject, for example, for one of your presentation. That's nice. So we will clarify the project and the numbers. Nice for me. And then the last part of the first day was dedicated to a short analysis of the drawbacks of wood compared to other materials we know well, and the main sentence I've mentioned is that wood, unfortunately, is not an engineered material. So its composition can be defined by humans. We cannot modify the ingredients with which wood is produced by the tree, by nature, and this is of course a big difference with other materials with which we can play with their formulation, adding special additives to modify their properties. This is something we can do with wood, and this is also the reason why we have to study this material. We have to know very well, and also we have to learn how to protect it, how to use it, and as I said at the end, how to possibly modify its properties. Then we can go on, entering in the specific analysis of this material, starting from this scheme I've already mentioned. We will start with the morphology, so we will see this material with our eyes. So we will study the morphology of wood. Morphology is the branch of biology dealing with the form of organisms. So we will simply look at a piece of wood and consider how it's morphologically composed and which can be the properties we can derive. Then we will use a microscope to enter inside the material and looking at its anatomical composition. So the structure, which also can tell us many important information to consider in order to derive some of its properties, and finally more in detail with the tool of the chemistry. We will analyze its chemical composition. Our course is not strictly scientific. It will like to give you some basic knowledge related to the industrial use. So the scientific part it's considered, it's important, but what I would like to do with you, it's this continuous continuous trip from the composition to the properties, and going back, going on, and using the two parts to understand well what this material can be used for, with the limits and so on. So it will be not too much scientific, not too much practical. I will try to stay in the middle. Do you know how a tree grows? This is a tree after 1 year, the second year, third year, and 4th year. Normally, I ask to my student what happened if I plant a nail. Please don't do, because it's not good for the tree. What happened if I plant a nail here at the height of 1 meter? Where can I see the nail after 4 years? So I put the nail here in the middle of the trunk, 1 meter from the floor, and then I come back after 4 years, where the nail is. Do you have any idea? No ideas? Can I see the nail at the same position here? It's somewhere here, because the tree grows continuously. So
I think it will be in the same position.
Exactly.
Maybe internally, I don't know.
Yeah, you are perfectly right. So maybe if I come after 4 years, presumably I don't see the nail because it is inside the tree, but at the same height I've placed in the beginning, because the trees, we can imagine like a series of cones, concentric cones. So this is the tree after 1 month, when the seeds start to produce the first part of the tree. Then the tree grows in this way. Okay. So if we have planted a nail here, after some years we don't see anything, because as your colleague says, correctly says, it is inside, in the same position where I put in the beginning. So the tree grows as a series of concentric cones, connected by the roots and the branches. But what's interesting for us is this part. Okay, so also I think this picture can be familiar to you. If we cut a tree, we can see the external part is the bark. It's a sort of protection, of natural protection produced by the tree. Then there is a little layer here called the cambium, producing new cells in the external part. The cells form the bark. In the inner part, the cells form the wood. Then normally we can see two different parts. The softwood, it's the youngest part of the trunk, and the hardwood, which is the oldest part. Because coming back to this story, it's clear that the central part of the trunk is the oldest, because the tree grows on the external circumference. Okay, so the hardwood is the oldest part. In the middle, the peak, the central part of the tree. I think we are familiar with the growing rings. And a question that I immediately ask you, how can we calculate the age of a tree? I think this is known from the elementary school. How is it possible to calculate the age of a tree?
Yeah, simply by
counting the number of rings.
Yeah.
Yes. Do you know why?
It seems that every year the ring increases by one.
Yes, because in the areas like the one like Italy and Germany, normally during the year there are the tree forms two rings. One during the hot season, where the tree grows very rapidly, and so normally it forms a light color ring, very porous because of the speed of the growth. In autumn, the climate change, and so the growth of the tree is reduced, and the tree forms a second ring, which is denser, also darker in color. So this is the reason why we can count the number of rings, and in principle we can derive the age of the tree. But this is partially right. It's not always possible to calculate the age of the tree. Why do you think this calculation is not always possible?
Because some accidents could happen and stop the growth, I think.
But yes, you are right. For example, there could be some particular years that can be very hot, also during during winter, and so in principle you cannot note a difference between the rings. So some rings can be lost due to particular years where the climate was different. But there is another important reason, which depends on the area, on the geographic area where the tree grows. What do you think, for example, for the trees growing in Africa, close to the equator? What happened there? Do we have differences in the climate during the year?
No, there are not difference, and there is not so much water in the equator.
Yeah, but the first sentence was the one I would like to comment. If you go in Africa or in South America, close to the equator, you don't have seasons during the year, and so you don't see the rings. Because there are no differences in the tree growth during the year. So normally the trees coming from Africa, from hot areas, they don't present rings, and the wood it's more homogeneous without this drawings which derives from the differences in the climate from the hot seasons and the cold seasons. This means that, for example, for designers and architects, it's fundamental to know if a certain wood species comes from Europe, from North America, or from hot areas like Africa or the middle of South America, because the appearance of the wood will be completely different. I could say that normally trees coming from Africa, they have good properties, but in terms of appearance, they are boring. I could say they don't present the characteristic of, for example, if you think to the olive tree or other European wood species with this nice appearance due to the growings deriving from the rings, which are appreciated by the final consumers. So this story of the growing rings is not only scientific data, but it has also some consequences also on the appearance of the various wood species and of the possible markets they could have. Remember, the rings derive from the differences, the climatic differences we have during the year, but only in certain areas of the world. So there are trees with rings and other trees without the presence of the rings, and the market, the value of the tree depends also on the appearance they have and how much attractive they could be toward the final client. But there is another point we have missed. considering the story of the age of the tree, you can, in principle, calculate the age of the tree only if you cut it at the bases. If you cut the tree a certain height, as you can see clearly in this picture, you lose some ring, and so your calculation is not right. So you can estimate, you can say estimate the age of the tree only if you cut it at the basis, where you can see all the rings starting from the beginning of the life of the tree. Another important curiosity about the rings is that, as we have considered before, they can tell us something about the climate of specific periods of the history. You know that some trees can live for centuries, and so if we cut a very old tree, considering, for example, the width of the ring, we can derive if during a certain period the climate of the earth was cold or was on the other side was warm, depending on the width. If the width is wide, presumably in that period the climate was warm. If the wings are narrow, it means that the climate was presumably very cold. There is a science, a branch of the science, of the wood science, called dendrology, which is used exactly to derive some information about the climate of the past, just analyzing the form, the shape of the rings. And in some cases, it's interesting that such studies were able to associate the rings to some particular events. For example, the explosion of a volcano that produces a lot of powder in the air, so reducing the sun radiation for some years, and the trees growing in that period reveal narrow wings due to the reduction in the sun radiation. So I like this kind of study. So from the rings of the tree, you can derive something about the climate of the previous of the past, of the last of the previous centuries, for example, and also associating this to some particular event that happened in certain periods. So for me, it's fascinating that story. Another point I would like to consider is the difference between softwood and hardwood.
Excuse me, Prof.
Yeah, please.
I have a question.
Yeah.
Okay, so we can see the difference between some stagionality of the different year, looking inside the wood.
Yes.
But this difference could be mechanical too.
Yes.
So,
yes.
Okay.
Yeah. You are right. when the tree grows fastly, normally the rings are wider, more porous, and so, for example, the density is lower. You are perfectly right. When the rings are closer, they normally are denser. So also the mechanical properties of the tree are normally improved. This is right, and also in the production of new trees, such consideration are taken into account in order to place the trees at the right distance in order to allow the growing in certain condition, producing a certain type of wood with certain properties. I don't want to go more in detail, but you can imagine that trees deriving from plantations normally are produced considering that the faster is the growth, the better is for the producer, of course. So normally the same wood deriving from plantation has a lower density than trees deriving from virgin forest, because in the virgin forest the trees for different reasons grows slowly compared to the trees growing in plantation. So even the mechanical properties, but not only, could be different from the wood deriving from natural forest compared to plantations. Did I answer you?
Yes, but I have another question. Because if the growth is faster, we have more porosity.
Yeah.
So is it better for the insulation or not?
Yes, yes, you are right. Because as we will see, trees are characterized by a cellular structure, and so the less is the density, the better is the insulation properties of this material. Yes, you are right. Good.
Okay, thank you.
Okay. Softwood and hardwood. We were here. Softwood. So softwood is the liquid flowing inside the cell. So it's rich of nutrients. So this is the liquid the tree uses for growing, for every metabolic function of the tree. So softwood, the name says that this part of the wood is rich of these nutrients, sugars, starches, salts, all the nutrients that the tree needs for its life. On the other side, hardwood, which is the central part and the oldest part of the tree, normally is darker than the external part. I have a picture here, in the other direction, I think. You see, this is a special tree with this big difference in the color between hardwood in the middle and softwood in the outer part. As I said before, the hardwood is the oldest part, and inside hardwood, there are no nutrients, but the trees produce some special substances, in particular polyphenols, tannins, and others, which have a particular function, protection function for the tree. So normally, the sapwood, which I said is rich of nutrients, is not the right material, especially for products that must be exposed outdoors. And the reason is that because it's rich of nutrients, some insects or some fungi, some microorganisms can use the nutrients inside wood for their needs. So the sapwood is normally very sensitive to biological aggression. And so in principle is not the right material to be used, especially, as I said, for elements like windows, garden furniture, and other elements to be used outdoors. On the other side, the substance I mentioned before that the tree produces in this part of the tree, tannins, polyphenols, and others are a sort of natural natural preservatives. So they protect the wood from the aggressions of the microorganisms or living organisms. They are sort of poison for such living organisms. So hardwood is the right material to be used for producing, as I said, windows or other elements to be used outdoors. So remember, sapwood, rich of nutrients. Sap is the liquid the tree uses to transport the nutrients. So this part is sort of good dish for living organisms. The hardwood is exactly the opposite. It contains some natural preservatives against the biological aggressions. And so this is the most valued part of the tree, the hardwood. We will consider at the end of this part one, when we will consider the safety of wood, but I think it's good to anticipate something. I said that inside this part of the tree, there are some natural substances which act as a sort of poison for living organisms like insects and fungi, molds, and so on. But we can consider that what is dangerous for other living organisms can be dangerous also for us, for the human beings. And this is exactly what's happening. The substances that are present here in the hardwoods can be dangerous also for the human beings. Okay? Can be dangerous also for us. And in particular, they can be cancerogenic. So they can induce cancer to the human beings. And this is the reason why all the companies dealing with wood and doing a particular operation like sewing, like sanding. So all the operation which produce wood dust. This company are subject to some controls by the local authorities. They have to install special plants in order to remove wood dust. All the operators must be protected against wood dust because, as I said, wood dust, in particular this part, contains cancerogenic substances. And the reason is simple. These substances are produced by the tree to protect itself. So the tree produce some preservatives, some poisons against living organisms. We are a living organism, of course, and so these substances are dangerous also for us. This is the simple story. Okay, so we have quickly analyzed the section of this trunk, and we have derived some interesting information about the story of the rings, how the tree grows, the hardwood and the softwood, the different properties in terms of durability, especially in outdoor condition. We have derived some information about the appearance of wood. Now we know that if someone offers to us a flooring of an African wood species, we can imagine that the appearance will be homogeneous without particular drawings, particular artistic effects caused by the rings, because there are no rings in the African trees, especially those close to the equator. We have derived also, yes, the story of hardwood and softwood, and I think it's more or less all about the hydrology. Also, it's interesting. This could be a subject for one of your presentation if you decide to present something at the end of this course. And I think it's more or less all. This is a picture of a particular wood species where the distinction between hardwood and the softwood, it's the contrast. It's a very clear. It's not always. You can see this clear distinction. In some cases, for example, here in our laboratory, for certain wood species, we have to use some chemicals which tell us if the wood we are analyzing is softwood or if it is hardwood, because it's not always so evident the different color between the internal part and the external part. I'd like just to introduce this this part, but we will continue during the next lecture. I think we will go on for 5 minutes, not more, and then we can close our lecture for today. How the the wood is composed in terms of anatomy. So what can we see with a microscope when we look at the wood section? So this is a typical picture of a piece of wood. Just a moment. Can you see me in the little screen? Yes.
Yes, we can see you.
Yes.
Yes.
Okay. So we can imagine a wood piece like this collection of little tubes I have with me. So you can imagine a tree grows in this direction, and looking with the microscope, we could see a sort of cellular structure like the tubes I have in my hands. So the tree is composed by many little tubes like this, and the majority of them are placed in the vertical direction. So this is a model of a tree trunk. This is the real situation where you see all these little pipes placed vertically, and you see also the difference between the late wood, so the ring produced during the cold period in autumn, winter, and here the large cells, the large tubes produced during the spring, the spring and summer months. So you see that the density is higher for this ring, so the color is darker. And this is the early wood producing in the warm period. What is interesting is to see these little pipes placed vertically, and some others, these are called arrays, that are placed in the orthogonal direction. This is the typical structure of softwoods, like pine, like spruce, and others like this. So it's very homogeneous, apart from the rings, but the cells are all equals, are all also the direction is vertical for the majority, for the large majority of the cells. So this is the typical structure of this family of wood species. On the other side, if we consider, if we look with the microscope to the anatomical structure of hardwoods, like oak, like cherry, many others, we can see a completely different appearance. There are also in this case the cells that are places, mainly places vertically to the axial the direction of the tree. But we can see that there are different types of cells. Some of them are very little, and some others are very big. called vessels or pores. And in hardwoods, there are many rays placed in the orthogonal direction. So the anatomy of softwoods, it's more simple, simpler, it's more homogeneous. The anatomy of hardwood is more complex. There are different types of cells, more arrays. So um, the hardwoods, the anatomy of hardwoods, it's different from that of softwoods, and this is reflected also in the evidence of the two types of woods. I would like just to show you. I think we are familiar with pine. You see the growing rings, but the surface of this kind of wood, as I said before, is quite homogeneous because the cells are placed mainly in the vertical direction. There are rays are not significant, and also the dimensions and type of cells are equal. For oak, it's an hardwood. The situation is completely different. There are different types of cells, little cells and bigger cells, big rays, and so also you can see the aspect, the appearance of such wood is less homogeneous than that of pine. It's I could say it's more wood than pine. In terms of aesthetics, it's absolutely better than pine. So this is the reason why architects and designers normally prefer hardwoods instead of pine. If you go to a furniture shop, normally you can find kitchens made of oak, kitchens made of cherry, kitchen made of chestnut. The also floorings, oak floors are very common, are really appreciated by the final consumers. It's very rare to see kitchens made of pine. Normally, you can see only, for example, in Italy, if you go in some houses close to the mountains, pine it's used because it's the material of the forest that are outside the house, but normally in the houses of the cities, Milan, Berlin, London, Paris, normally you can find hardwoods, not softwood. Softwood is used for buildings, but not too much for furniture. And the reason derives from their anatomical structure. As I said before, the anatomical structure of softwoods is quite simple, homogeneous cells that are all equals with a few arrays. In the case of hardwoods, the trees go in a different way with more, I could say, fantasy, with the different cells, more rays, different dimensions, and so on. So also the final aspect, the final appearance of the two families is different, and as I said, the market appreciate more the appearance of hardwoods instead of that of softwoods. Okay, I think it's a time to finish our lecture of today. As we said also last time, it's not easy for you and also for me to go on with this remote instruments. They are useful, and I agree that we are lucky to use them, but the interaction with you is difficult. Unfortunately, we cannot have continuous discussions as we could do in the classroom. This tool does not is not particularly suitable to being interactive. So I think it's time to close, also because it's more difficult also for me to maintain the concentration without looking you into your eyes to understand if everything is going on in the proper way. But in any case, we will maintain this option for the future lecture, because we don't have alternatives. Okay, any question before we close the lecture? No. I hope you are not all sleeping.
No, prof.
Okay. As I said last time, I will maintain the connection for 10 minutes. If some of you would like to contact me after the lecture, you can do. And I'd like just to remember that we will meet again next Wednesday at 4 o'clock in the afternoon. You know where to find me with the email for any curiosity, any reason, any possible suggestion for your presentation if you like to present something. And I would like also to remember to Clara and to Giovanni to send me the list of students who are interested in the splitting of the exam into parts. That's all for today. Have a nice weekend, and see you next week. Bye-bye.
See you.
Thank you
Bye.
very much. Bye.
Thank you very much.
Thank
Thank
you.
you.
Goodbye.
Goodbye.
Thank
Bye.
you, Professor. See you.
Goodbye, Professor.
Bye. Ora un attimo impegnato. Sì, no, lei ci sono.
Dai un momento, passo di là che ti aggiorno su due robe, nulla di urgente però.
Sì, guarda, volentieri.
Ok, vengo a trovarti.
Ora, perfetto. Robin, have you something to ask to me?
My computer broke down. I guess it's over already, right?
Okay.
Yeah. Okay, thank you.
Bye-bye.